Aloha and welcome to Lesson 13. We're still on Module 5. This is Video 1 and we're still talking about finding the area of rectangles and figures with fraction or mixed number side lengths. So you see we have something interesting on our screen today, and if you can't tell, these are made up of little pieces that I cut out and laid down there for you. So sorry if some of them are a little bit crooked, but just observe them for a minute. And what do you notice or wonder about the shapes that you see on the screen? Okay, you might be noticing that they are all in sort of the same shape, right? They're roughly rectangles or squares. They all have a hole in the middle, right? I put these on top of this grid paper, mostly just so I could move them around a little bit better. But you can see they all have a hole in the middle. And you can see that the shaded figures on the outside, you might be able to notice that they are in different shapes. Okay, and maybe you're thinking about the area of either the rectangles that they make up or the side lengths there. Okay, now you might notice that each of these figures is made up of these shaded figures that are called tetrominos. Okay, so think about dominoes, right? This is a tetromino. This is 4, so 4 is the tetra, right? That's the Greek prefix tetra, which means 4. And like domino, a figure composed of 2 squares, so this is a tetromino, a figure composed of 4 squares. So these are in a line right here. These are in a square next to each other. Then these, a little bit harder to see, but if I pull them apart, you can see they're in L shapes, right? These are all L shapes put together. See that? Okay. And then these are 3 on the bottom, 2 on top. And then these are kind of like Z's or S's, 2 and 2. Okay. So you might know something about these from the game Tetris, right? These are, right? Tetris, tetromino. There's also pentominoes, but those would be 5 squares put together. So these are tetrominos. I got these from a Teachers Pay Teachers project and cut them out so that you could see them. You can also buy the colored blocks and squares. So there's 5 different types of tetrominos, and each tetromino is a composite figure because it's composed or made of other shapes. Okay, so composite figure. Let's just write down that word so that we can think about composite, composed. Sorry, can't see that. I'll put it right here. Composed of different shapes. So it's a composite figure. They all are made up of 4 squares. If they're all made up of 4 squares, then they have the same area, right? But they are different shapes and they have different perimeters, but they're all made up of 4 squares. So today we are going to determine the area of composite figures with fraction and mixed number side lengths. Okay, so let's jump into it. Go to problem 1 in your book and see where it says each square in the tetromino shown, and we're looking at this tetromino. I'll sort of separate it out for you. That tetromino, I think in your book it's the other way. I don't know if I have any that go that way. Anyway, it's 4. It has the side length of 1.5 inches. So what is the area of the tetromino? So if this shape by itself has a side length of 1.5 inches, and it's pretty small, but I'm going to put it there and make it a little bit easier for you to see. What method can you use to find the area of this entire thing? How can you figure out the area of one square, and would that help you find out the area of the whole thing? And if you know the area of one square, yeah, can you figure out the area of the whole thing? Okay, so think about what different methods you could use. If we know that one side length, I think we have a dog letting itself in here, one side length is 1.5. 1.5, did it tell us? 1.5 inches. So we do have a unit, 1.5 inches. So that means that every side length is going to be the same, right? Okay, so if you're going to figure out the area of one square, then you know that length times width is going to equal area, right? So length times width equals area. Okay, so that makes sense. I think I could maybe zoom in on that a little bit more, but that's fine. How can you find the area of it? You have to multiply the mixed numbers, right? And we talked the last lesson about how you could draw an area model. You could do break apart and distribute, or you could change them to improper fractions or fractions greater than 1 and multiply them together. So how would you like to do it? Let's see, if we changed it to fractions greater than 1, that would be 2 times 1 plus 1, 3 halves, right? Double check your work by thinking, okay, 1 is the same as 2 halves, plus 1 more would be 3 halves. 3 halves times 3 halves. If our numbers are smaller, it's a lot easier to do this, isn't it? So 3 times 3 is 9. 2 times 2 is 4, because I'm multiplying, so I am going to use my multiplying my denominators. 9/4, 2 and 1/4, because 4 times 2 is 8, right? 2 fit inside, and I have 1 left over. 2 and 1/4 inches would be the area of one of them. All right? Now, how can I find out the area of 4 blocks if I know the area of one of them is 2 and 1/4? Does it make sense to multiply that by 4, right? Okay, so then I have to take 4, and it's a whole number, so I'm going to put it over 1 times 2 and 1/4. Okay, so can I do something similar to what I did before? I could use area model, I could use break apart and distribute, or I could change it to a fraction greater than 1, right? How many fourths are in 2? That would be 8, right? 4/4 and 4/4 is the same as 2, and then 1 more fourth, so that would be 9/4 times 4 over 1. 4 times 9 is 36. That's 36/4. Okay? 36 divided by 4 is 9. So that means that the area of the entire thing would be 9 inches. The area of 1 is 2 and 1/4 inches. Okay, now one last question before we go to our next video. If the tetrominoes are all composed of squares that are the same size, if the area of this one is 9 square inches. What are the areas of the other tetrominoes? Like this one, and this one, and these. Are they all 9 square inches?